In this lecture, we're going to review polynomials. In order to talk about polynomials, we must first discuss monomials. So, a monomial is the product of a constant and a variable raised to a non-negative integer power. It takes the form a times x to the k power, where a is constant, x is some variable, and k is greater than or equal to 0 and is an integer. When we're looking at a monomial, the constant a is called the coefficient of the monomial, and the power k is called the degree of the monomial. So let's look at some examples of monomials. For the following, we want to determine whether or not they are monomials. If they are, we want to identify the coefficient and the degree of the monomial. If not, we'd probably want to tell why they are not monomials. So we have 7x cubed, 1/2 x, negative 3x to the fourth, and 2x to the 1/2 power. For our first example, 7x cubed, this is a monomial. The coefficient is the number that goes with the variable, so the coefficient is 7, and the degree is the power on the variable, which must be an integer, so the degree is 3. For our second example, 1/2 x, this also is a monomial. The coefficient is 1/2, and the degree is 1. For negative 3x to the fourth power, this also is a monomial. The coefficient is negative 3, and the degree is 4. And finally, 2x to the 1/2 power is not a monomial, and that's because the power, k, is equal to 1/2 is not an integer. Remember, in order for this to be a monomial, the power on the variable has to be a non-negative integer. So since this is 1/2, that's not an integer. That makes this not a monomial. Similarly, if it were a negative value, like negative 2, that would not be a monomial. Now that we've talked about monomials, we can talk about polynomials. Basically, a polynomial is just the sum of several different monomials. By definition, a polynomial in one variable is an algebraic expression of the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus the values of n will decrease on the exponent until we get down to a sub 1 times x plus a sub 0. Where the values of a sub n minus 1, a1, a0 are all constants called coefficients, n is greater than or equal to 0 as an integer, and the leading coefficient, or the first coefficient, a sub n, and the value n is the degree of the polynomial. So let's do an example with polynomials. For the following polynomials, we want to determine what the leading coefficient is and what the degree is. Our first polynomial is 3x to the fifth plus 4x cubed minus x squared. See if you can figure out the leading coefficient and degree. Remember, the degree is going to be the highest power that you see, and the leading coefficient is going to be the coefficient or constant that goes with that same term. So for this example, our leading coefficient is 3 and our degree is 5. The highest power we see is the fifth power, so that's our degree, and the constant that goes with that term that has the fifth power is the 3, that's our leading coefficient. Our next example is 4x squared plus 2x to the seventh power plus 3x. See if you can figure out the leading coefficient and degree of this polynomial. Again, the degree is going to be the highest power that we see, so in this polynomial, the highest value we see on an exponent is 7, so this has a degree of 7, and the leading coefficient isn't the first coefficient we see, but the one that goes with the term that has the highest power, so our leading coefficient is 2. So this is just an example that shows that a polynomial isn't always written in order where the highest degree is first. Okay, so next we want to talk about adding and subtracting polynomials. In order to add and subtract polynomials, we're going to take the following steps. First, we want to distribute or multiply to remove any parentheses that may occur. And then we want to combine like terms. So any term that has an x squared will be combined together. Any term that just has an x will be combined together, so on and so forth. Let's try an example. We want to find the sum x cubed plus 3x squared plus 2 plus x squared minus 4x plus 4. So we'll start by distributing or multiplying to remove parentheses. There are no values to distribute or multiply, so we can just drop the parentheses here. So we have x cubed plus 3x squared plus 2 plus x squared minus 4x plus 4. We want to combine our like terms, so we're going to put all of our terms that have x squared together, all of our terms that have x together, and all of our terms that don't have any x's together. So that's going to give us x cubed plus 3x squared plus x squared minus 4x plus 4 plus 2. And if we simplify by combining these terms together, we'll get our final answer, which is x cubed plus 4x squared minus 4x plus 6. Let's look at another example. For this example, we have x squared minus 3x minus 4 minus the quantity x cubed minus 3x squared plus x plus 5. The first thing that we want to do is remove our parentheses, so we'll need to distribute the negative throughout the second set. Removing the parentheses and distributing the negative throughout the second set of parentheses gives us x squared minus 3x minus 4 minus x cubed plus 3x squared minus x minus 5. Now the last thing that we want to do is match up our like terms and combine them. So again, I've color-coded these. The x cubed term is in black, x squared is in blue, x is in green, and the constants are in magenta. So we're going to match those together and then combine them. So combining like terms gives us negative x cubed plus 4x squared minus 4x minus 9. Next we want to talk about multiplying polynomials. To multiply polynomials, what we'll do is we'll distribute each term and then combine like terms. So, for example, we want to multiply 2x minus 3 times x squared plus x plus 1. To complete this multiplication, we're going to take the terms from the first set of parentheses and distribute them throughout the second set of parentheses. So the first term in the first set is 2x. So we're going to multiply 2x times the entire second set of parentheses. And then the second term is negative 3. We'll also distribute that throughout. After we distribute these, we'll combine like terms. So distributing the terms from the first set of parentheses is going to give us 2x cubed plus 2x squared plus 2x minus 3x squared plus 3x plus 3. And the last thing that we need to do is combine like terms. So again, these are color-coded. The x cubed term is in black, x squared is in red, x is in blue, and our constant is in green. So we're just going to put together the terms that match. And that gives us 2x cubed minus x squared plus 5x plus 3. Now, while the distribution method discussed on the previous slide can be used for multiplying any set of polynomials, there are some special multiplication formulas. The first is what's called the FOIL method, and this is used when you have the product of two binomials, so two polynomials that each have two terms. FOIL stands for first, outer, inner, last. So, for example, we want to multiply together x plus 3 times x plus 5. This is the product of two binomials, so we can use the FOIL method. For the FOIL method, we first multiply the first terms together. X times x gives us x squared. Then we multiply the outer terms together. X times 5 gives us 5x. Next, we multiply the inner terms together. 3 times x gives us 3x. And then we multiply the last terms together. 3 times 5 gives us 15. So we have x squared plus 5x plus 3x plus 15. The final step is to combine the like terms. So we can combine 5x and 3x to give us 8x, and the product x plus 3 times x plus 5 will be x squared plus 8x plus 15. Another formula that we can use is called the difference of two squares. If we see a product of the form x minus a times x plus a, we can use this formula. X minus a times x plus a will give us x squared minus a squared. For example, 3x plus 2 times 3x minus 2. Now this matches the form of our formula, x minus a times x plus a. So we can simplify this to be the first term squared minus the second term squared. which would be 3x quantity squared minus 2 squared. And if we simplify that, that gives us 9x squared minus 4. Now, of course, if you can't remember this formula, you can always FOIL it out. Another formula deals with the squares of binomials. If you have a binomial x plus a squared, that winds up being x squared plus 2ax plus a squared. And if you have x minus a quantity squared, that's going to be x squared minus 2ax plus a squared. For example, we want to expand x plus 5 quantity squared. So this matches up with the first of the two formulas, so we can plug those in. The first term in the binomial is x, and the second term is 5, so if we plug those into the formula, we'll get x squared plus 2 times 5 times x plus 5 squared, and if we simplify, we'll have x squared plus 10x plus 25. The next special product deals with cubes of binomials. If we have x plus a cubed, that can be written as x cubed plus 3ax squared plus 3a squared x plus a cubed. And if we have x minus a quantity cubed, that's x cubed minus 3ax squared plus 3a squared x minus a cubed. So, for example, we want to expand 3x minus 2 quantity cubed. This is going to deal with the second formula. Our first term is 3x, and our second term is 2. So we can plug those into the formula for x and a, and that'll give us 3x cubed minus 3 times 2 times 3x squared plus 3 times 2 squared times 3x minus 2 cubed. So now we need to simplify, so we'll start by simplifying the exponents, which gives us 27x cubed minus 3 times 2 times 9x squared plus 3 times 4 times 3x minus 8. And finally, we simplify the multiplication to give us 27x cubed minus 54x squared plus 36x minus 8. The next special product is called the sum of two cubes, and for it we could use the formula x plus a times x squared minus ax plus a squared equals x cubed plus a cubed. And the difference of two cubes says that x minus a times x squared plus ax plus a squared equals x cubed minus a cubed. Now these two formulas are going to be more useful to us when we talk about factoring, so we're not going to do any examples using them right now. Next, we want to talk about the division of polynomials. Remember, when we're dealing with division, we write the thing that is being divided underneath the division sign, and outside of it we write what we're dividing by. The thing that is being divided is called the dividend, and what we are dividing by is called the divisor. Once we do the division, we get an answer called the quotient, which is written on top of the division sign, and we get a remainder, which is written down below. Now, the division can be rewritten such that what we're dividing is equal to the quotient times the divisor plus the remainder. As a special note, when we're dividing polynomials, you must account for each term in the dividend. If any term is missing, we have to use a 0 as a placeholder. So for example, if you don't see an x squared term, but you have an x cubed term and an x term, you have to write in a 0 for your x squared term. Otherwise, your answer is going to come up wrong. So for our first example, we want to figure out 3x to the fifth minus x squared plus x minus 2 divided by 3x cubed minus 1. Notice that our dividend, 3x to the fifth minus x squared plus x minus 2, is missing the x to the fourth term and the x cubed term, so we're going to need to put zeros in to hold those places. So we write out our division problem as follows. We put the dividend underneath the division sign, so 3x to the fifth plus 0x fourth plus 0x cubed minus x squared plus x minus 2 goes under the division sign, and the divisor, 3x cubed minus 1, will go outside. So now what we want to do is we want to figure out, just looking at the first term of the divisor, what would we need to multiply the first term of the divisor by to get the first term of the dividend? So what would we need to multiply 3x cubed by to make it 3x to the fifth? And that would be x squared. If we multiply 3x cubed by x squared, that would give us 3x to the fifth. So the next step is to actually do that multiplication. Let's multiply x squared times our divisor, 3x cubed minus 1, and write that underneath the dividend. So x squared times 3x cubed minus 1 gives us 3x to the fifth minus x squared. Notice we lined those up with the matching terms above. And then the key to division is after you do that multiplication, subtract that. So we're going to subtract this from above. So 3x to the fifth minus 3x to the fifth gives us 0. Negative x squared minus negative x squared also gives us 0. And we bring down our remaining terms. And we would go through another round with what's left. So we have x minus 2. We ask ourselves, what can we multiply 3x cubed by to give us x? And there's nothing that can do that. So basically, once the degree of what you have left is less than the degree of your divisor, you're done. So our remainder here will be x minus 2. So our quotient is x squared with a remainder of x minus 2. Let's do another example. So this time we want to divide x to the fourth minus 2x squared plus 3 by x plus 2. Again, we're missing terms in our dividend, so we'll have to use zeros to hold their places. So writing this out using the division sign, we have x to the fourth plus 0x cubed minus 2x squared plus 0x plus 3 under the division sign, and x plus 2 being our divisor is outside. So again, what we want to do is we want to ask ourselves, what would we multiply the first time of the divisor by to get the first term inside the dividend? So what do we have to multiply x by to get x to the fourth? And that would be x cubed. So we go ahead and do that multiplication, x cubed times x plus 2, and write the result underneath the dividend. X cubed times x plus 2 gives us x to the fourth plus 2x cubed, and we subtract that from above. So x to the fourth minus x to the fourth gives us 0, and 0x cubed minus 2x cubed gives us a negative 2x cubed. We bring the next term from the dividend down, so we have negative 2x cubed minus 2x squared down here, and we go through another round. So ask ourselves, what would we have to multiply the divisor x by to get negative 2x cubed? And that would be negative 2x squared. So we go ahead and do that multiplication, negative 2x squared times x plus 2, which gives us negative 2x cubed minus 4x squared, which we're going to subtract from above, giving us, we bring the next term from the dividend down, which gives us 2x squared plus 0x, and we go through another round. So what do we have to multiply x by to get 2x squared? And that would be positive 2x, so we go ahead and multiply that out, 2x times x plus 2, and write it underneath the dividend. 2x times x plus 2 gives us 2x squared plus 4x, which we'll subtract from above, leading us to 0 minus 4x. We bring down the last term from the dividend, so we have negative 4x plus 3, and we go through one final round. What would we have to multiply our divisor by to get negative 4x? So what do we multiply x by to give us negative 4x? And that's going to be negative 4. So if we come down and do the multiplication, negative 4 times x plus 2 gives us negative 4x minus 8, which we will subtract from the terms above, which gives us 11. So the degree of 11 is less than the degree of our divisor, so this is going to be our remainder. So we have a quotient of x cubed minus 2x squared plus 2x minus 4 with a remainder of 11. Now, sometimes we'll be asked to write our answer in a special way. So in this problem, we're going to write it in the form of dividend equals divisor times quotient plus remainder. So x to the fourth minus 2x squared plus 3 equals x plus 2 times x cubed minus 2x squared plus 2x minus 4 plus 11. And finally, we want to briefly talk about polynomials in two variables. So for example, if we have x plus 3y times x minus 3y, we should be able to deal with that. And essentially we're going to treat this the same way. We just FOIL it out. So our first terms would be x times x gives us x squared. The outer terms would be x times negative 3y, which gives us negative 3xy. The inner terms would be 3y times x, which gives us 3xy. And the last term would be 3y times negative 3y, which gives us negative 3y quantity squared. We can simplify this by combining like terms, and we get x squared minus 9y squared.